This is a video from section 3.5. It's on implicit differentiation. So far, the only functions you have seen can be described by expressing one variable explicitly in terms of another variable. For example, we could have y equals x e to the x. Notice how y is defined explicitly in terms of x. Or y equals sine of e to the x plus x squared. So again, y is defined in terms of x. In general, we are able to write y equals f of x. Some functions are defined implicitly by a relation between x and y. For example, on number 1, we have x squared plus y squared equals 4xy. Sine of xy equals xy squared, that's number 2. And x squared plus y equals 2x. So notice here that the functions are defined implicitly. So notice how x's and y's are mixed up together on one side of the equation. Now grant you, on number 3, notice how I can get y by itself and by moving x squared over to the other side. So you notice here that y equals 2x minus x squared. So it's possible to be able to solve for y in number 3. But if you look at number 1 and 2, that's not always going to be possible or easy to do. Okay. Now, in some cases, we can solve for y as an explicit function of x. So just like in number 3. In other cases, it isn't easy or even possible. And so we're going to use a method called implicit differentiation to find dy dx. And let's have a note here. It is always assumed that the given equation determines y implicitly as a differentiable function of x. So this method can be applied. And we're now going to take a look at some examples. So the directions say, find dy dx by implicit differentiation. And so what I'm going to do is go through examples and then describe what I'm doing. And let's go ahead and take a look at number 1, example 1. Suppose I had this one, 2x squared plus xy minus y squared equals 2. So what I'm going to do is I'm going to differentiate both sides with respect to x. So I'm going to take the derivative of the left side, which is the derivative of 2x squared plus xy minus y squared. And I'm going to set that equal to the derivative of the right side, which is 2. The derivative of a constant is 0. The derivative of 2x squared is 4x. Okay? Now, when I have x times y, remember here, we're differentiating with respect to x. Okay? And so let me create a little room here. Let's do this. So I'm going to apply the product rule. So I'm going to take the derivative of x, which is 1, and I'm going to multiply by y. Add. And then I'm going to take x and multiply by the derivative of y. But remember that you're differentiating with respect to x. And I think this is potentially the confusing part. So the derivative of y with respect to x can be written as dy dx. Okay? And then to take the derivative of y squared, remember that you're taking the derivative with respect to x. And so I'm going to apply the chain rule here. And so the derivative of y squared is going to be 2y times the derivative of y with respect to x, which is written as dy dx. The derivative of 2 is just 0. And so what I want to do is I want to isolate any term that has a dy dx on one side of the equation. So in other words, I'm going to isolate this term and this term. So we're going to leave that on one side of the equation. So what we're going to have is x dy dx minus 2y dy dx. And I'm going to set that equal to the following. So I'm going to move that 4x and I'm going to move that y over to the other side. And so I'm going to have negative 4x minus y. Okay, so let's write that down on the next page. So we have x dy dx minus 2y dy dx, and this is equal to negative 4x minus y. So I'm going to factor out a dy dx because that's what's going to allow me to solve for dy dx, right? And so I'm going to multiply by x minus 2y. And I'm going to set that equal to negative 4x minus y. And so dy dx is going to be negative 4x minus y divided by x minus 2y. Now, once again, I want to remind you, it's not always easy to be able to solve for y in terms of x. So this would be an acceptable answer for the derivative. Sometimes you are going to have x's and y's mixed up. That's fine. And that's how you do the first example. Let's take a look at a second example. Suppose I had x e to the y equal to x minus y. So I'm going to differentiate both sides with respect to x. Okay? So on the left side, I'm going to apply the product rule. So I'm going to take the derivative of x, which is 1, and I'm going to multiply by e to the y. Plus, I'm going to write the first function, which is x, and I'm going to multiply by the derivative of e to the y. But remember, you're differentiating with respect to x. And so I'm going to write e to the y times dy dx. So this is an application of the chain rule. So we're doing the chain rule over and over and over again. And this is what your instructor will be going over in more detail in class. Okay? So this is the product rule. Now on the other side, we're going to get the derivative of x with respect to x is 1. And then we're going to subtract dy dx. And so everything with the dy dx should be on one side of the equation. Okay? So now here we get e to the y plus x e to the y dy dx is 1 minus dy dx. And so I want this term and I want this term to be on the same side of the equation. Okay? And so to do that, we're going to get the following. We're going to get x e to the y dy dx plus dy dx, right? So in other words, I'm just going to add dy dx to both sides. And I'm going to set that equal to 1 minus e to the y. So what did I do there? I just took this e to the y and moved it over to the other side. And so factor out a dy dx, and you get x e to the y plus 1 is equal to 1 minus e to the y. And so to get dy dx on the left side, I'm going to divide both sides by x e to the y plus 1. So dy dx is 1 minus e to the y over x e to the y plus 1. And that's how you do the second example. Let's take a look at another example. We'll call this example 3. Suppose I had this one. Suppose I had sine of xy equal to cosine of x plus y. So I'm going to take the derivative with respect to x on both sides. Now, again, this is the chain rule. You're applying the chain rule here, okay? The derivative of the outside function sine is cosine. So I'm going to take cosine of xy, and I'm going to multiply by the derivative of that inside, which is xy in this case. Okay? And I'm going to set that equal to, now, the derivative of the cosine is negative sine. So I get negative sine of x plus y times d dx, right, of x plus y. So I get cosine of xy times, I'm going to apply the product rule. So I'm going to take the derivative of x, which is 1, and multiply by y. And I'm going to take x and multiply by the derivative of y with respect to x, which is dy dx. Common mistake people are going to make is they're going to write 1. And you don't want to do that because you're differentiating with respect to x. On the other side, we get negative sine of x plus y, and then the derivative of x is 1. The derivative of y is written as dy dx because remember, you're differentiating with respect to x. So I'm going to distribute this. So we get y cosine of xy plus x cosine of xy dy dx. That's on the left side. And on the right side, we get negative sine of x plus y minus sine of x plus y dy dx. Now, what I'm going to do is I'm going to collect the terms that involve the dy dx. So it's this one and this one. Okay? So I get x cosine of xy dy dx plus sine of x plus y dy dx. That's on the left side. On the right side, we get negative sine of x plus y minus y cosine of xy. I'm going to factor out a dy dx, and we get x cosine of xy plus sine of x plus y. That's on the left. And on the right, we get negative sine of x plus y minus y cosine of xy. And so we want to get dy dx by itself. And so we're going to we're going to divide both sides by x cosine of xy plus sine of x plus y. And we get the following. We get negative sine of x plus y minus y cosine of xy divided by sine of x plus y plus x cosine of xy. And that's example number 3. Let's take a look at one more example for this video. So let's take a look at example 4. Suppose I had the following. We could do this one. Suppose we had sine x cosine y is x squared minus 5y. So let's differentiate both sides with respect to x. You get the derivative of sine x cosine y with respect to x is the derivative of x squared minus 5y. Okay, now we're going to apply the product rule. So we're going to take the derivative of the sine, which is cosine, and we're going to multiply by cosine y plus sine x times the derivative of cosine y, which is negative sine y, but by the chain rule, you have to multiply by the derivative of y with respect to x. That's the key, is that dy dx. So we're going to set that equal to 2x minus 5 times dy dx. So cosine x cosine y minus sine x times sine y dy dx is equal to 2x minus 5 dy dx. So we're going to collect all the terms that have the dy dx on one side. Okay, so I'm going to move the 5 dy dx over to the other side, to the left side, and I'm going to move cosine x cosine y to the right side. So when I do, I get the following. I get 5 dy dx minus sine x sine y dy dx. That's on the left side. And on the right side, we get 2x minus cosine x cosine y. So if we factor out a dy dx, I get 5 minus sine x sine y equal 2x minus cosine x cosine y. Now, to get dy dx by itself, I'm going to divide both sides by, I don't have to put the equal sign there, I'm going to divide both sides by 5 minus sine x sine y. So we get 2x minus cosine x cosine y divided by 5 minus sine x sine y. And that'll conclude this video for section 3.5, where we did 4 examples of implicit differentiation. Okay, thank you.